Alright, in this video we'll do a few examples of determining whether a function is even, odd, or neither. First, before I do these examples, I want to remind us about some algebra things that you're definitely going to need to know for solving these sort of questions. First, so if you have x, negative x squared, this is the same thing as negative 1 times x squared. So that's the same thing as negative 1, negative, you can distribute the square amongst products, times x squared. So negative 1 squared is 1, so 1 times x squared, which is the same as x squared. So negative x squared is the same thing as x squared. And that's going to be true of any, whenever the power is even, that's going to be true. Okay. Now if you were to change it so that the power is odd, so negative x cubed, so that's going to be negative 1 times x cubed, negative 1 cubed times x cubed. So negative 1 cubed is still negative 1. So this is basically negative x cubed. So whenever you have, to a odd power, the negative sign doesn't, go away as it did in the even power. So if you know those two rules, basically determining if an odd, even, or neither should be relatively simple. So let's go ahead and get started with this first example here. So determine if whether it's odd, even, or neither. What you do is you just plug in negative x. That's what you do. So let's go ahead and, so we'll have negative x to the fourth minus negative x squared. Okay, so these are even powers, so it'll be negative x to the fourth is the same as x to the fourth because that's an even power. And then negative x squared is the same thing as x squared. Okay, so this is exactly the same as f of x. So f of negative x is the same as f of x. So that is an even function. Okay, now let's go ahead and do the same thing for this one. Plug in negative x. So we'll get negative x to the third minus 2 times negative x. All this over negative x plus 1. Negative x to the third is negative x cubed, right? Because it's to the third power. Negative 1 to the third power is still negative 1, so the negative stays there. Minus, actually, this minus and that minus make a plus, so 2x over negative x plus 1. Alright, so I could maybe pull out a negative sign up top. So I'll have negative x cubed minus 2x if I were to pull out a negative sign. And then I'll have negative x plus 1. Okay, so when we're looking at this, we see, oh, okay, so the top looks like this function, but the bottom does not, right? So this is, f of negative, this is not the same thing as f of x, and it's not the same thing as negative f of x. So this is neither odd or even. So this is neither. Okay, now this last example. Go ahead, we'll start off plugging in negative x. So negative x squared plus 1 divided by 5, negative x cubed plus 2 times negative x. Alright, 3. Now negative x squared is just negative x, or is just x squared plus 1. So then this negative x cubed is still negative x cubed, right? So I just pulled the negative sign out there, but negative x cubed, right? The negative sign doesn't go away when it's cubed. And then this plus, and then that negative makes this a minus 2x. Alright, so I'm trying to see if I can make this look like what we have here, or something, maybe the negative version of it. So the top already looks good. The bottom is the negative version. So let me go ahead and pull out a negative 1 from the bottom. So I'll have negative 5x cubed plus 2x. Alright, that's the same thing as if I were to, so the negative, let me go ahead and erase that. So the negative, it could be out front completely, right? Just because it's on the bottom, it could be out. So I'm going to pull it out. 2 plus 1 divided by 5x cubed plus 2. Okay, these two things are the same thing. So I just pulled out the -1. Okay, and yeah, that is the negative f of x, right? Because this is f of x here, right? And then there's the negative version of it, so that's negative f of x. So this is f of negative x. So f of negative x equals negative f of x, which is the definition of an odd function. So this is odd.